In section 8.3, we're going to be talking about inscribed angles. So if we have a circle and we have an angle that looks like this, we would call angle ABC an inscribed angle. And what that means is that any angle, an inscribed angle is basically just any angle whose vertex is on the circle. And one of the theorems that we're going to learn about this is that an inscribed angle measure is half of its intercepted arc. So here, angle ABC, that angle measure is going to be half of what arc AC measures, okay? So if arc AC was 90 degrees, angle ABC would be 45 degrees. If angle ABC was 10 degrees, arc AC would be 20 degrees. And that's the relationship there. So let's look at an example problem. I want to figure out what the values of A and B are in this diagram. So let's start with A. I can see that it's this arc here, and it's intercepted by this angle. So going from the angle to the arc, we're going to end up multiplying by 2. So if that angle there is 60 degrees, then A would be 120 degrees. And that's it. Now let's look at B. So B looks like it's an angle. The arc that it intercepts is that 120 degrees plus that 30 degrees. So if we're going from the arc to the angle, we're going to divide by 2. So it looks like this arc here is 150 degrees. So if I cut that in half, we get that angle B is equal to 75 degrees. So in conclusion, A is equal to 120 and B is equal to 75. The last theorem that we're going to talk about today is about opposite angles in an inscribed quadrilateral. Again, inscribed just means that like the endpoints or vertices are touching the circle. So here we have a quadrilateral or a four-sided shape. All of the points there are on the circle. If you have a situation like this, know that opposite angles of an inscribed quadrilateral are always going to be supplementary. So angle B plus angle D would add up to 180, and angle A plus angle C add up to 180. And those are the theorems that we're going to work with this section.